Welcome to AI Podcasts. Today we're digging into a new AAAI 2025 paper called Attention-Driven GUI Grounding, and the short version is pretty wild.
I'm listening. Give me the headline first.
The authors show you can make a model find where to click on a screen by using the model's own attention maps, no fine-tuning at all. Think of it like borrowing the model's internal spotlight to point at the right button.
So, no extra training, just reading the model's mind a little. Who did this work?
Led by Ming with Lingqiao at the Australian Institute for Machine Learning, University of Adelaide, with a collaborator from the University of Wollongong.
Nice. Before we get into the how, what problem are they solving exactly?
It's the GUI grounding problem. You have a screenshot and a natural language command like click billing or open settings. The system needs to return the screen location to click. It's a core skill for any desktop or web agent.
Right, because if the agent can't point, it can't act. What's been hard about that?
Most strong systems fine-tune a vision language model on piles of annotated screens until it can spit out coordinates. That works, but it's expensive and brittle. New apps, new layouts, new aspect ratios, you often need more training. And a lot of models are great at describing a screen, but not so great at landing on the exact pixel.
So how do they get around the training?
Their method, which they call TAG, short for Tuning-Free Attention-Driven Grounding, taps into attention maps already present inside a pre-trained multimodal model. They used Mini CPM Llama 3V 2.5 as the base, but the idea is general.
Walk me through it step by step, like I'm holding a laptop and trying to follow along.
First, instead of going straight from the user's command to a coordinate, they ask the model to describe the target in words. So if the user says click billing, the model might elaborate that it's a text button labeled billing in the left sidebar.
Like getting a quick verbal sketch before you start pointing. That's clever.
Exactly. Then from that description, they pick out the key text tokens. Not every word is equally useful. Billing is more important than words like the or button.
And then they somehow connect those important words to the pixels?
Yep. Inside these big models, text tokens attend to visual tokens. You can think of visual tokens as compressed chunks of the image. TAG tracks how strongly the chosen words attend to those visual tokens, and then how those visual tokens attend back down to the image patches.
Like tracing a chain of influence from the word billing to the chunk of the screen that looks like billing to the exact spot on the screen.
Perfect analogy. One more trick. Not all attention heads are useful. Some heads are like well-tuned radio antennas, others just hiss. TAG scores heads by how much they focus on the relevant visual tokens and keeps only the best few. Then it combines the signals into a heat map and picks the brightest point as the click.
So they're not training a new model, they're curating which parts of the attention to trust and then projecting that trust onto the pixels.
That's it. Describe, select tokens, select heads, project to pixels, click.
Okay, but does this actually beat trained systems, or is it just a neat demo?
It holds up. On a text-heavy benchmark they created, the method jumped accuracy dramatically over the base model and even outperformed a strong fine-tuned method. On a well-known grounding benchmark that mixes mobile, desktop, and web, it was competitive overall and clearly stronger on text elements.
You set a new benchmark. What's that about?
They call it OCG for optical character grounding. They start from real website homepages, run OCR to get text boxes, and then stress test with different aspect ratios. It's a way to test whether a method can still find the right word if the screen gets stretched or squashed.
Oh, aspect ratio is such a pain. You resize a window and everything shifts?
Exactly. TAG handled those shifts much better than the base model. The intuition is that the attention from the word to the region stays meaningful even when the layout changes, as long as the text is there.
What about icons and little widgets that don't have text?
That's where TAG helps less. Improvements are there, but smaller. If there's no clear text anchor, the attention signal has less to latch onto. So the big headline is, robust wins on text. Icons remain a challenge.
Makes sense. You can't attend from billing to a tiny gear icon if the word gear never shows up in the conversation or on the screen.
Right, the model's internal spotlight is language guided. If the language doesn't name the thing or relate to it, the light is dimmer.
What did they compare against besides their own base model?
They compared to prompting strong general models and to fine-tuned grounding systems. Importantly, they kept the prompting comparable, and for their method they avoided any fine-tuning, so it's a clean test of attention-only grounding.
Any agent-style tests, not just static screenshots?
Yes, they evaluated on a real web task dataset, measuring whether the predicted point fell inside the target elements box. TAG raised the base model and landed in the same ballpark as the best fine-tuned agent for that metric.
That's impressive for a zero-tuning approach, but you know me, I have questions. What are the gotchas?
A few. First, TAG needs access to the model's internal attention weights, and also the vision encoder's connections back to the image. If you're using a hosted closed model that doesn't expose those, you can't run TAG directly.
So deployment depends on how open your model is. Not a showstopper, but it narrows the choices.
Exactly. Second, their new benchmark relies on an OCR system to define ground truth text regions. OCR quality can change with versions, so replicability depends on freezing those annotations. To their credit, they share code and data, but it's something to watch.
And they mostly showed results on one backbone, right?
Right. Mini CPM Llama 3 v 2.5. It's a solid choice, but showing the same effect on 2 or 3 different multimodal models would make the generality claim even stronger.
What about speed? Pulling attention from lots of layers and head sounds, well, not free.
Totally. They don't frame it as a latency paper, and extracting attention maps does add overhead. For an interactive agent, you'd want to measure how much that costs and whether you can cache or prune.
I'm also curious how they choose how many heads to keep. Is that a fixed number?
They rank heads and keep the top few per token. It's a simple rule and it works, but tuning that number might matter across models or screens. It's a lever you'd want guidance on.
Still, I love the spirit of it. It's like discovering the model already knows where things are, and you just have to ask the question the right way.
That's the exact vibe. Modern multimodal models store rich cross-modal alignments. TAG is a recipe for surfacing those alignments without spinning up another training run.
If you were building a practical GUI agent tomorrow, how would you use this?
I'd route text-anchored queries through TAG first. For click the word billing or open privacy policy, attention-driven grounding should be your fast path. For icon-heavy tasks, I'd hybridize. Combine TAG with a cheap icon detector or a small classifier. And I'd standardize prompts so the model produces consistent target descriptions.
And to make it more general, I'd try at least one more backbone. If the gains hold on a different architecture, that's a strong signal this isn't a one-off.
Agreed. I'd also lock down a fixed evaluation set with frozen OCR outputs, and then report latency so teams can decide when to use TAG versus a simpler heuristic.
Quick recap for listeners who are jogging or, making coffee and only half listening.
Sure. The paper shows you can localize GUI elements by harvesting a pre-trained model's own attention, no fine-tuning. You prompt the model to describe the target, pick the most relevant words and the most focused attention heads, project that attention back to pixels, and click the hottest spot. It shines on text elements and stays robust even when screen shapes change, while icons are still tougher. The trade-offs are access to internals and some questions about speed and generality.
Nicely put. My takeaway is that grounding might not require retraining a huge model every time. Sometimes the answer is to read the signals it already produces and, well, listen carefully.
Exactly. Less training, more steering.
That was Attention-Driven GUI Grounding from OpenAI 2025 by Ming, Lingqiao Liu, and colleagues. If you're building agents, give TAG a look and try it on your own screens.
Thanks for hanging out with us. This is the AI Podcast. I'm Evan.
And I'm Maya. See you next time.